All right, so today we're going to do something a little bit different. Normally, what we would do is have a student share their screen and have y'all try to figure out how to solve the app. This time, what I'm gonna do is I'm gonna share my screen, and then we're gonna go through the completed code. But as we go through the completed code, I'm gonna be asking everyone, like, what do you think this function does? And I want y'all to try to look at a completed version of a function and try to figure out what the function is trying to do. Essentially, what I'm doing is trying to teach you how to read someone else's code. Um, Let me pull the code up before I start to share. Okay, I'm gonna share my screen. Okay, so what I have up is the completed code. What we're gonna do, we're gonna go through the memory game again. Memory game. This is the memory game right here, right? Now, we're gonna do a little recap. Like we're gonna start from the beginning, and I'm gonna ask like, what do you think each of these functions is doing? So we know that the very first thing we have to do is press the start button. So if I just go to where it is in the HTML, we see that the start button has an on click. The on click has this fires this function, show MG directions. So I'm gonna go to it in the code and I want y'all to tell me, what do y'all think this code is doing? Just kind of like line by line. You can ask me to go around, just try to look around in the code if you need further clarification. But like, it will probably help if everybody download the completed code also. So yeah, like what do you think this does for us?
Shows the direction of where the squares should appear.
Sorry, I didn't catch it. What you said? You said it does what? Like let's start line by line. What do you think what is line 37 doing?
Removing the attribute. Let me see.
So remove attribute, right? Like where does this come from? Where do we get this remove attribute function from?
That's one of the no, no, what is that? I don't
It's
know
the
if it's a property or a
util.js.
method of the.
Yeah. So it's a function. So like try to look around in the code, try to figure out like where we even get this from, this remove attribute function.
The remove attribute function is in the utility.js folder or util.js folder.
Right,
It's a
exactly.
function out of there.
Right. So I'm inside util, right? So what is this doing exactly? Like what let me put these two files side by side. Just here. So we have gonna be a little tricky. That's probably too small. Okay, so I don't think we're gonna be able to put these side by side. So it looks like this remove attribute takes two parameters, right? Like trying to walk me through like what do you think is happening?
Well, it's the element and the attribute.
Right, exactly. So we give it the element and we give it the attribute. Where do you think this is coming from? This remove attribute method?
It's coming from something like the if else statement. So if
Right.
this is this, then remove this. So basically like a true false statement. So if you have this, then it's this.
Yeah. So So I think what you're describing is the toggle attribute function that has like the if else statements. But like, let me go back to remove attribute. This remove attribute method, this is a built-in method that comes with every element. Every HTML element gets this built-in method. If we go back to memory.js, where we first saw it, we're passing in this as an element. How does this come out to be an element? Like why is that an element? That first parameter.
Because that function is calling the element, the tag, it's calling a div from, oh, I'm sorry, it's calling MG strings. So it's like document dot get element by ID. That's what that get by ID is doing. That get by ID function is doing. And
Right,
document dot get element by ID creates an element.
right, exactly. So this get by ID is inside of util.js. So yeah, we're passing in the ID, like Jay was saying, and then we're doing document.get element by ID. And that this returns the element, and then we're returning the element from this function. So that is why we have an element here. And what is this part here? This second parameter.
That is an attribute
That
of,
you're removing this.
Yeah,
Right,
that's the non-display
Yeah,
that
you're
we're
removing no display. Yeah.
right, exactly. If I do command and then click on it, it takes me back up here. This is that string, that no display string. So essentially what we did in all in one line is we got by ID with this function. This function returned an element. So we placed an element here, and then we placed the attribute, and then we took that element and we did element dot remove attribute, and then we removed the attribute. Um, I want y'all to notice like how I'm tying all of these functions together. It's a lot of times you're gonna see a lot of like functions being tied together this way. So you'll be going back and forth through files in order to try to figure out what exactly is going on. But that's why it's so important to label your functions to say exactly what they're doing. Okay, so that removes this no display attribute. Whenever we remove that attribute, what happens? Like why are we even removing that attribute?
to show the directions that are on below it, right?
Right, exactly. And it shows it, right? So so like why so it does show it, right? But why is it like showing it? Like what makes it be removed in the first place? Why is it even not on the screen to begin with? To reword it, we know that this element right here, the one with so where is it? MG strings, the one with this ID, right? Let me go to the HTML. So this is the directions right here. We know that this is not being shown on the screen. Why is this not being shown on the screen?
Because of the no display attribute, right?
Right, the no display attribute, but where in the code are we saying that stuff with a no display attribute can't show up on the screen?
That's
Where,
CSS, right?
right, exactly. So that's everything we did. The CSS is saying anything with no display attribute gets this display none CSS rule. So um, so yeah, that's essentially it. So we're removing the no display attribute so that it removes this CSS rule, thereby showing it on the screen. And just quickly, what do you think this one does? This set attribute. Well, first, where does this set attribute function even come from? That's the first question.
util.js,
Right.
like Naya said.
Oh, I didn't even hear it. My bad. Or is this put in the chat or? Oh no.
Yeah, she put it in the chat.
Yeah. So yeah, this actually sets the attribute, and set attribute adds the attribute back. So, all right. So I'm gonna press that button now that we understand completely what that function does. So it shows the directions, and then it removes that start screen. So now I'm gonna go to this HTML element, and we know that this has an on click also. And the on click is memory game start. I'm gonna look for that, and we're gonna try to figure out what that function is doing. Okay. So can someone tell me just line by line? I guess we sort of went through these ones already. I'm not even gonna go back through these. So we're doing the set attribute, and we're adding this no display attribute to the directions. And then we're doing remove attribute. So we're removing the no display attribute on MG board. Let me look at what string that is. It's something with an ID of MG board. If I go to the HTML, we can see that this is actually like that game board. You can see like the top left, top right, bottom left here, bottom right. That's the actual game board. So that is what the first two things do here. So the next one is the set timeout. How is set timeout used? Like what is it used for? Why are we even? Go ahead.
Set timeout is the function that runs the CPU function after a second, right?
Right. Exactly. And I could have literally like removed all this extra stuff because all I have to do is pass it a function.
What was the CPU move function again? The 48?
Right. Exactly. So yeah, let's go to CPU move. All right. So we know after a second, we're gonna run CPU move. Now let's just kind of like dissect some of this stuff. And all of it may not make sense right away, but we can sort of guess our way through it. So after a second, or let me click this real quick. After a second, it ran that CPU move. And if you notice after a second, what happened was this box was highlighted. Let me just refresh in case somebody didn't catch it. I'm gonna press start and I'm gonna press this. And after a second, you're gonna see one of these boxes highlight, the same box highlighted, coincidentally. So now we know that happens 1 second after. Let's try to figure out like what this function is doing for us. Obviously, this function does that, but let's try to like dissect it. The first thing it does is it says, is CPU move true? Now, can someone just kind of like guess at what that's supposed to mean?
Don't you got to set a variable to make it true before you run like a...
Yeah. So we're setting this equal to true so that we can tell JavaScript whose turn it is. And I'm naming this specifically like is CPU move. Anytime you name Booleans, like a variable that's supposed to be a Boolean, you either do by convention and you can do it however you want. But most of the time you're going to see is CPU move or like has CPU move. Like there's certain words we use. So is and has are like two very common like words we use to define like a Boolean, for example. So I will just get into the habit of using these because they're very like descriptive and they help try to point somebody in the right direction. But yeah, this is to us telling the computer whose move it is. And we're gonna see this used somewhere. Now, I'm looking at this right on line 49. Like we didn't initialize it with like const or let. Like, can someone tell me like what do they take from that? Like why are we able to set this to true without initializing it with const or let?
Because it has a global scope, or
Right.
because it has a higher priority scope or a higher hierarchy scope. I don't know how to. I forgot to word it.
Yeah. Well, it's global. It's global, and the reason it's global is because this is actually defined up here. We already defined it. And like, what's the significance of using the let keyword? Why don't we use const?
Because you're gonna be changing let.
Right. Exactly. So that's why we define it with let. So now we're setting equal to true. It's global. Global means this variable can be accessed anywhere inside of any of these functions, anywhere. And honestly, a lot of these JavaScript files can access this same variable too, but let's just, I mean, in the context of this file, all of these functions can access this variable. We're gonna see it being used. So yeah, so after 1 second, it sets this to true. And then it runs this function, get random index from array. Where is this function located?
The utility folder.
Right, exactly. And what does this function do for us? This is it inside of util.
It is picking a random index from any given array, from an array that you pass into the function.
Right, exactly. And we're able to do that because we're literally making use of this length property. It already tells us how like the numbers to choose from. We get the random index, just like you said, and then we return the array with that index, basically getting something random within the array. So if I go back to 51, we're setting a variable move to some random value inside of MG CPU options. Now I'm gonna go to that. Honestly, if I'm gonna press command, and we can already see like the values in there, but if I click on it, it brings me up here. So we're essentially getting these random, we're getting a random string from here. Why are we getting a random string from here? Like what do these strings represent?
Each
The
index in the array.
squares.
Right, exactly, each square. So in the HTML, we have all of these squares, all of those squares have IDs to them to identify them, unique identifiers. So top right, top left, bottom left, and then bottom right. So we're essentially selecting a random ID that's associated with those squares. So now that we know that this contains some random square, let me just like put in the comment, let's just say like we had chose, what was it? It had highlighted bottom left. Let's just say move was bottom left. I'm just gonna put that there just so we can like have a visual of like what's going on. Then what it does is it does CPU moves dot push and then moves. What is this line doing? Why, like, what does this push thing even do? And what is CPU moves?
It is adding that string to the array,
Right.
the
What's the name
CPU
of the
moves array, which has been
right?
set to blank.
Right, exactly. So if I go up here, we have CPU moves, and it's an empty array here. One thing I want to note. So let me, before I say that, so the push method, in case anybody didn't know, just like you said, it adds something to an array. It adds whatever you put inside of here. So if this moves was MG bottom left, it adds that to this array. Now,
It adds it to the back of the array, right?
Right, exactly. It has it right at the end of the array. I do want y'all to actually towards the end towards the end I'm gonna come back to this and I'm gonna explain something else, but I don't want to go too far off track. But so yeah, we're adding to this array. Now let's say this array now is equal to this. Just to have a visual of what's going on, right? So now we're defining some variable. We're just naming it delay. Hold on one moment. Okay. So we have some variable delay. Right now is 0. So we don't have to worry about it right now because we're not interacting with it, but we're gonna get back to this. We're gonna get back to like this delay variable. CPU moves dot for each. What does for each do when you do the CPU moves dot for each?
It iterates through
Loops
the
through
array.
the, oh, go ahead.
Right, exactly. Yeah, it loops through the array, iterates through the array. Yep. So it's going to loop through this array essentially, and it's going to run this function every time. Remember this literally just takes a function, but we threw this function in like this. Whenever you throw a function inside of a whenever you throw a function as a parameter like this, what's the name? Like this function has a specific name to it. Anybody remember what that's called?
Was it a ghost function?
What was it?
Tertiary something? No.
No. No. It starts with an A.
This function.
Oh what?
Right?
No. It's hold on.
Hold on. I think I see it.
Anonymous?
Right. Exactly.
Oh man, I said a ghost function. Damn, same thing though, bro.
Right. Yeah. So yeah, it's an anonymous function, and the reason it's called anonymous function is because we didn't name it anything. We just literally just threw like the function body in there. But yeah, ghost function is. I mean, I get why you why you said it though.
I was in the building though.
Yeah. So all right. So every time we iterate over this array, which is this right here, each thing we're iterating over is box. So let's say just box, like we just want to say box is this, because this is the only thing that's inside of this array. So we're using this set timeout again. So we're doing set timeout and then delay. So that's literally just going to run after 0 seconds because we defined delay here. And then we're going to run highlight CPU move. And then we're going to get to this. It's going to highlight CPU move after 0 seconds. But remember, even though it says 0 seconds, all of the code runs before like 0 seconds hit. Like all of the JavaScript has to run before we even start firing these set timeouts. So it sets that up for us to run highlight CPU move after 0 seconds, and then it adds 1 second, well, 1,000 milliseconds to delay, which is 1 second. We're going to get back to this, but after it comes out of this, because it's going to come out of this because it only has one thing in there, it's going to go to another set timeout, and then it's going to run is CPU move false, and it's going to do that after 1,000 because it was already 1,000 when it came out of here. So 1,000 minus 1,000, which is 0. So it's gonna run this after 0 seconds. This one, and recall like this was 0 seconds also, but these things run in order. Like this runs first because we set that one up first, and then this one runs after that because we set that one up after it. So I'm gonna put those back, and now we're gonna go inside of highlight CPU move. We're going here and we're going to pass a box. Box is this right here, MG bottom left. So if I go here, let's break this down. So remember, this is bottom. I should have just copied it. MG bottom left. Let's start copying and paste. So move is MG bottom left. So what is this line doing? Line 42. Where do we get add class from? Where's that come from?
util.js.
Right. So in util.js, we have an add class function. What does this do?
It adds a class to any given element.
Right, exactly. You pass an element, it does class I add, so we can add that class and we add the class. So we already know what this does. We're getting by ID. And the thing that we're getting by ID is the thing with MG bottom left as an ID, which is one of those squares. So essentially we passed in a square here. And then we're adding a class of CPU click. This here. What does this do? Whenever we add this class, what does that do?
Changes the color of the boxes to blue. And I cheated on that one.
Yeah. So how do we know it changes to blue? Like what tells us that it's going to change the box to blue?
The cascading style sheet, no, the CSS file.
Yeah, yeah. So yeah, is that right? CSS. I'm sorry if this is like a little too in detail. But yeah, it's it comes from the CSS file. Background color blue. Cool. So what we did was we added the class so that we can give it that blue background, and that was that flash that we saw. That was here at the bottom. And then we're doing another set timeout, and we're doing remove attribute. I'm not sure if we went over this one yet, but yeah, remove attribute is in the same spot. Is inside of util.js, and it just does the opposite of what add class does. You pass an element, you pass in the class, and it does class list. Instead of add, we remove the class, and we're removing the class. And by removing the class after half a second, we're making it look like the box flashed.
So how did you pick those numbers? How did you pick the 1,000 and the 1 second and the 5 seconds, or 1,000 milliseconds and 500 milliseconds?
Right. Then he minus the 1,000 and all that. Like, yeah,
Right.
Good
Yeah.
question.
Yeah, that's a good question. So what I wanted to do was only show it for 500 seconds, no matter I'm not 500 seconds, half a second. Yeah, 500 milliseconds. Yeah. I wanted to only show it for half of a second, right? So we know that delay, no matter what delay is, even if delay is 0, if it's 1,000, if it's 2,000, it doesn't matter, because this is going to run. Once this runs, it's going to highlight it, and then after half a second, it's going to remove it. It's going to remove the highlight. So it doesn't even matter how, like, what delay is. All that matters is when this function runs. And as far as like why I picked those numbers, like I just kind of played around with them, to be honest. Like whatever looked right for me, I just put those numbers in there. And I knew that there had to be some separation between when I add the class and when I remove the class. And a half a second it just seemed like it was right. So that's that. So let me see what happens after that. Okay, so after highlights, remember we said it runs this one first because this was 0. Remember, and then this was 0. So it ran that. It did the highlight, then it put it back, And then it ran this one here, is CPU move false? Then the computer is done, like it's done doing stuff, because now there's no more functions being run at that point. The only thing the computer did was, so if we recap it, what the computer did was it put the move into CPU moves, and it did the highlight. And then it told JavaScript whose turn it is. At first, it was the computer turn, and after all those highlights and stuff is done, now it's not the computer turn anymore. Now it's your turn. That's how we get this back and forth. That's how we get the back and forth from the code through the game. So what I'm about to do now is I'm gonna put a debugger, since we know what all of these do. There's still a few functions that we have to go through, but I'm gonna put a debugger inside of CPU move. Then I'm gonna press this box after I do it. I'm gonna do that through source, and I'm just gonna close out all of these. I'm gonna close all of these so I can show you how to open it fresh. Remember when we did this, you press this to open it up. You see all the files here. Open up the JS file. I'm gonna go to main.js. I'm gonna close this back, and I'm gonna go down to, what is it? CPU move, line 48. Line 48 is here. All right. And before I click it, actually, let me select this with the I want to go to the HTML first. This box, whenever I click it, we're clicking make memory game guess. We're firing make memory game guess. Let's go to that and try to figure out what's going on. And notice we pass in MG bottom left. That matches the ID of the box, and we do that with all of them. Make memory game guess, we have MG bottom right, that matches this ID, so on and so forth. So let's go to this function so we can figure out what that does. Make memory game guess. There's a lot of stuff. It passes an ID. So the ID was, let me go back. The ID is going to be this, MG bottom left. It's going to pass that in. And then it's going to run this. It's going to say, if is CPU move return. Why did I put this line here? What does this do?
If you guessed it right,
Say it again.
if the person guessed the same box as the computer.
Well, not yet.
Yeah.
So go ahead, Jay.
Oh, it's checking to see if it's still the computer turn. If it's the computer turn, then it's gonna kick out that function.
Right.
It's gonna stop you from doing anything.
Exactly. Remember, this is CPU move. This was used up here. Right here it says that it's true that it is the computer turn. So let's say the computer was going, right? And then you click one of those boxes. The computer didn't finish yet. Like, it's still saying that it's true right here. So if this is true, it's going to hit return. It's going to hit this return. When we do if else statements, we can do this. But since it's only one line, we don't have to put these brackets here. So I'm just going to put that right after this to do a shortcut. And this return keyword exits the function. As soon as we hit return, it just jumps out of the function. So it's not going to run anything at the bottom. All this stuff is going to be skipped. So essentially what that does is it prevents you from running anything inside of this function, or anything under line 106 if it's not your turn yet. So what does, this line right here, 107, this is what you were referring to, Diamond, when you were saying it's checking to see if the move is correct.
That was special. I don't want her to take the wrong answer on my behalf.
I'm sorry. Yeah, I didn't even. Oh, I'm sorry. That's my bad. But yeah, we passed in the ID, right? MG bottom left. and then it's doing this check right here. What is click index? Where does that come from?
The moves you set for it.
I'm sorry, what was it?
Is that the moves you set for it? So bottom left, bottom right.
Well,
Line 17.
right, so line 17, click index is 0 right now, right? So it's 0. So what we're doing is we're checking CPU moves at the 0 index. So the very first thing inside of CPU moves. Remember CPU moves, we filled it up here. It has MG bottom left inside of it. So we're checking to see if the first item inside of MG bottom left is indeed the ID that you passed in. And if it is, then we know that the first move that we just made is correct. If it's not correct, then it's game over. Let me quickly go through game over. Let's say we didn't click the right box, right? I'm gonna go to game over. Game over is here. This is basically set an attribute to the game board where we're adding that display, that no display attribute back, so we can remove the game board from the screen. And then we're removing the no display attribute from the home page, MG home screen. So this removes the game board. This adds back the home screen. This resets click index to 0. We're basically resetting the variables back. So we can start the game fresh the next time we go to start. And then we're setting the inner text of MG count to 0. And we'll get to why we're doing this after we go through this code here. But this is essentially resetting the game back to normal, to where it was. So let's say you made the correct move, right? First, it does a console log correct move. This is just for us. We don't need that inside of the code for it to work. And then what it does is it adds 1 to click index. And the reason it's adding 1 is because we already checked the 0 index, which is the very first thing inside of CPU move. Now we're going to increment that to 1. So when we go to click it again, we're going to check index number 1. We're going to increment it, and we're going to check index number 2, so on and so forth. But that's why this is there. But let's go back to the first index. The 0 index. We had this inside of it, and we click the right thing. We increment this, and then we go inside of this if statement. It says if index equals CPU moves dot length. Like, what can someone guess at, like what this could possibly mean? It's not obvious at all. But I just want to see if someone can just guess it. Why are we doing this check here? To see if the click index equals the length of CPU moves.
It resets the user's move back to 0. So then when you go to make your next guess, then you start from 0 and count up to make sure that y'all making the same type of the same number of clicks.
Right, but why are we using this condition before we start doing all of that stuff? Like, what's the significance of this equaling CPU moves dot length?
I feel like just to stop random moves. Yeah,
So this tells us when the computer is done clicking. Is done. Like, I'm sorry. It tells us when we've guessed all of the moves. Right now, we only got one thing inside of it, right? So when we check this starts off at 0 and then it increments to 1. So this being 1 says that CPU, like the click index keeps track of which index we're currently on inside of that array, right? And if we're at the length of this CPU moves array, that means that we've guessed all of the possible clicks that the computer made. Right now, the computer only made one guess. So the length of that array of CPU moves is 1. And since 1 equals 1, that must mean that we're at the end of it. And I think this will be more obvious once we start clicking more and more things, more and more squares. But yeah, I'm just saying has guessed all moves. And this is what I should have did, honestly, to make this more obvious. This is what that Boolean means. Has guessed all moves. So yeah, like you were saying, it reset, click index back to 0 so we can start guessing again. It resets its CPU move to true so that the computer can make a move. It sets up this set timeout. So after 1,000 seconds, it's going to do CPU move, where we already went through CPU move and what that does. And then it's going to increment guesses. Let me go to increment guesses. So we can try to figure out what that does, and that's here. So inside of increment guesses, we're first grabbing this by ID. We know what this does, get by ID. This is an element. The thing that has this ID is here, is this number right here. And this number shows up in the east on the screen here, this 0 right here. So essentially what we're doing is we're first grabbing this HTML element, this number. And by the name of the function, we're basically just going to increment it. So we grab this, we get the element, right? And then we get the inner text. Why are we doing parse int to the inner text? We know that this inner text is going to be 0, but why are we doing this? Like, what does parse int do?
Does that keep it to a certain number of digits?
You're thinking about the 2 fixed, but you in the right ballpark, like with where that method belongs, like the family of methods belonging to it.
To make sure that it's a number.
Right, exactly. Anything we grab back from the HTML, it's going to be a string every time. So this is what we put essentially, the string 0. Parse int turns it to an integer. So if that was 0.567, it's just going to turn to 0 because an integer is just a whole number. But that's besides the point. We're literally just getting the number version of the string. So now this equals 0, right? Now we're setting the inner text of this element that we just grabbed to 0 plus 1. So we're basically about to increment it to 1. And then we're not going to be able to get to this part yet because we're about to run out of time. But actually, just to quickly explain it, if y'all went through the videos and saw like local storage, we're basically getting a hold of what's in local storage, the score that's saved in local storage for the memory game. And then we're checking to see if that score is less than the current number that we're on. And if it is less than that, then we got to set the new high score. So we're checking the high score. We're seeing if the high score is, we're saying if we beat the high score. And if we beat the high score, we set the high score so that, it saves it for us for next time. But that's the quick explanation of that. If you don't know what local storage is, I would go through that section and look at local storage. But either way, we increment the guesses, and then after 1 second, we make the computer move. We always want to make the computer move after 1 second. The reason we're doing this is so that the game can seem more realistic. If we didn't put this 1 second here, the computer is going to go right after, like instantly, right after we're done clicking. And that's a bad user experience because we're not able to like keep up with that like just that speed basically. So that's why I'm using this 1 second before I start making the computer move. So we'll go right back through CPU move and do the same thing all over again. We'll get a random box. We'll push that random box to CPU moves. Now it'll have like a second thing inside of it. Let's say the second thing was MG top right. It had a second thing inside of it, and then we're gonna go through. We're gonna loop through this, and we'll start at delay 0, and then we'll increment delay by 1 second. Then once we go back to the top of this loop and fill in MG top left, now the delay is 1,000. So what this does for us is it runs MG bottom left first, and then 1 second after it runs this function with MG top right. So what it looks like is it's going to add a class, the highlight class, add the highlight class to this at 0 seconds. And then after half a second, remember we have that inside of that function, it's going to remove the highlight. And then after a second, it's going to run this function with MG top right. So now it's going to add the highlight class to this, and then it's going to remove the highlight class from it after like half a second after 1 second, which is 1.5 seconds. So essentially what we're doing is we're highlighting something and removing the highlight and making sure there's half a second in between each highlight. And that is what keeps the computer highlighting more and more stuff. If I click on this, now I'm done. It's going to run CPU move. Let me just get rid of that. Highlight, and all that was done within 2 seconds. It did this, it removed it, and it added a highlight, and it removed it again. And it's going to keep doing that over and over until you make a wrong move. And when you make a wrong move, when it does this comparison and you make a wrong move, it's just going to do game over. I'm just going to quickly, I know we're over. I'm going to quickly do spin. I just need 60 more seconds, and I'm going to put a debugger here. And I want to see I want y'all to see how this function runs. So I'm gonna click this. So now we're here. We clicked MG bottom left. So it's gonna say, is MG bottom left equal to CPU moves at index 0? So that's MG bottom left. That's the 0 index here. And it is equal to it. Since it's equal to it, it says correct move. It's gonna increment, click index. And then it's going to check to see if click index equals the length of CPU moves, and it's not equal to the length. We can visually see that it has another thing inside of it. So we're not done guessing the computer moves. So it's going to skip over that completely. I'm gonna hit play and nothing happens because that was it. Now, but it's still my turn. So now I'm gonna click this one. I click that. Now that one is MG top right. Now we know that click index is 2 now. I mean, it's 1 now. So now it's going to check if MG top right equals to CPU moves at index 1, which is MG top right. So we're essentially keeping track of all of the computer moves here and using a combination of the ID that we passed in and the click index to keep track of which move we're clicking. So I'm gonna do this, and I'm gonna increment this. Now this is 2. Now it's saying if 2 equals the length of CPU moves, which is 2, which is the indicator that that we've made all of the moves. And when we do make all of the moves, we reset click index back to 0 so that we're able to start from 0 again when we start guessing the move. We reset is CPU move to true because now it's the computer move. Our turn is over. And then it's gonna run this after it increments guesses. So right now guess is 1. I'm gonna hit play and it's gonna stop at this after 1 second. But you're gonna see this increment to 2. So now incremented to 2. 1 second later, it runs the computer move all over again and does the exact same thing over and over. It gets a random move. That random move is MG bottom right. I'm gonna hit play and you're gonna see bottom right highlight, bottom right here. So that is how this game works. That's how everything is tied together. Obviously, there's more than one way of doing this, but I wanted y'all to see how the mindset behind like how games are created and how all of this stuff sort of works together. Any questions?
You said you were gonna go back to a line.
Oh yes, I did. Thank you. So yeah, I wanted to go back to where is it?
48.
Yeah. Yes. It was this one. But yeah, I think it was I added a few stuff in here. But yeah, it was this one here. So CPU moves, right? This is that array, right? And when we initialize this array, we initialized it with the let keyword. Something I messed up on my end, I could have initialized it with the const keyword. And not that, I'm sorry, this one here, CPU moves. I could have put const here. I didn't have to put let. Now, the reason I can put const here, even though we're adding stuff to this array every time, the reason I can put const is because we're not changing the value. We're not resetting CPU moves to anything. CPU moves was already set to this array. Us adding to this array is not changing what CPU moves is set to. It's still set to this exact same array, no matter what. So we can put const here. And const, what const is going to do is going to prevent us from resetting this. So we can sit here and do push. We can do what was it? And all the other methods of adding to the array. But what we cannot do is CPU moves equals something. This is what const prevents. It doesn't prevent us from adjusting what CPU moves is already set to, if that makes sense. So yeah, you can use const here. And the same goes for objects. I mean, so the same goes for objects. This object is already set to something. I can add something to this object if I want. I can remove things from this object, but that doesn't mean that we're resetting it. We're just adjusting what it's already set to. That's like a possible interview question.
I thought you couldn't add to arrays.
Yeah, you can add. Yeah, we were adding it. You can add to the array. We were adding it with like push, with the push method. We can do push. We can do there's another one. Dot. Forgot. We can do or unshift. I think it is. Is it unshift? I don't know. There's another method. I can't even think of the name of it. But there's another one to add to the array with like this, with these methods. I don't think it's in here. CPU moves. Yeah, I don't think it's in here. I don't know. It's not showing up here. I think it's unshift though. I really think it's unshift. And that adds to the beginning of the array. So we add to the end of the array with this, and we add to the beginning with unshift. I'm pretty sure it's unshift, but y'all can like double check that after after this. But yeah, we can add to it. We just can't change the value. So Another thing we can do is we can add directly to an index. We can say the 0 index equals something. Add it that way. We want first index equals something else. But we're not resetting what is equal to, we're just adjusting what is already equal to by doing this.
Gotcha.
Any other questions? Thanks for reminding me of that, Jay. I see there's a lot of stuff in the chat. I don't know. I haven't been going through the chat. Let me see. Oh, it does matter how many equal T, it does matter how many equal signs it is. That's good. So triple equals means that it checks the type and the value. Double equals means that it just checks the value. For example, 1 triple equals 1. This is false. Because even though the value of 1 equals the value of 1, this type is a number and this type is a string. So the value and a string both have to equal each other for this to be true. So this would have to be it. 1 completely equals 1. But if we do the double equal, this is true because this is just checking the value. The value of 1 is indeed equal to the value of 1. So that's true. So yeah, those equal signs are very important. I try to always use triple equals. Like I rarely use double equal because I want to make sure that what I'm checking is exactly what I want to check. That avoids bugs. You don't want to you don't want to have those equal sign bugs because those things can be really annoying to find. So yeah. All right, let me go through.
I have a quick
Oh,
question.
right, yeah, exactly. Jay, you put it in there. Yeah, go ahead. You can ask your question.
So the way this code is set up, when you get it wrong and you go to play again, is it always going to start on that same box? Because that's like the first one you specify in the code.
So anytime it makes the so whenever we start back over,
Bottom left, but it always start with bottom left.
no, it doesn't. It doesn't. It does not. So remember, we fired CPU move, and CPU move got a random thing from that array. So it's going to grab a random thing every time. If I go
Oh,
back,
so
it was
you
just a
just
coincidence.
commented the, okay.
Yeah, it was just a coincidence that it grabbed. It's coincidence again. It's keep
That's
the
what I'm
same
like,
one.
so keep starting off the same box.
Yeah, there we go. Top
Okay.
top left. Yeah, it's it's random every time. Funny thing about being random though, like it's not completely random. Like behind the scenes, JavaScript has like a sequence of it uses like a function, some algorithm to calculate a random value. It's not truly random, but it's more random than we can do ourselves. That's just like the behind the scenes of like that random function. But yeah, it's a random one every time.
Okay.
Yeah.
I just kept seeing it doing the same one, and then I see you had put it in the comment. I'm thinking like, is it supposed to be?
Yeah. Oh well. So I put it in the comment because I saw that it clicked that one, and I was just using that example.
Oh,
Yeah, I was just using because I knew that was the one it had just clicked. So yeah. All right. So I'll stay if there's any other questions. And I'll see everyone else on Sunday. And on Sunday, we're going to do the tic-tac-toe. So go through, make sure first of all, make sure you understand this, and then go to the tic-tac-toe. Because if you don't remember, if you don't get this, like the tic-tac-toe is gonna like it's just gonna be on a whole nother level. Like it's much harder to understand than the memory game. So yeah, go through this video specifically. I think I broke everything down here. So go through this, go through the videos, whatever is the best way for you to study, and then go to the tic-tac-toe because we'll do a share screen with the tic-tac-toe, and then we'll finish tic-tac-toe on Tuesday, just like we did here with the memory game.
That's what's up, fam. Appreciate you, man.
Yep.
Peace.
Thank
See ya.
you.
No problem.
Right on.